Is we're going to be talking about normal distributions. And what a normal distribution curve looks like, it looks like a bell. A lot of times it's referred to as a bell curve. So if you see this type of thing happening, and I'm not very good at drawing these, I always get that back part goofy. But that's what a bell curve will look like. Okay, what's going to happen is right here in the middle is going to be your mean. Okay? Then, right here on both sides of it is one standard deviation away from the mean. Okay? So here's how it's listed and notated. It's listed as x bar plus that curly Q or x bar minus one of those curly Q's. Okay? Now, according to what they call the empirical rule, 34% of all of your data will lie within one standard deviation away from the mean to the right and 34% of it to the left. So that means that this right here is 0.34 and this right here is 0.34. If I were to take and add those two percentages together, I would have 68% of my data should be within one standard deviation of my mean. Then I'm going to have a second line. The second line is 2 standard deviations away. So I have x bar plus 2 of those curly Q's and x bar minus 2 of those curly Q's. And now I'm at 0.135, 0.135. And if I add all those numbers up together, if I add the 34%, which was 68, 13.5%, 13.5%, which should be 27, 68 plus 27 should be 95. I am 95% of my data is within that area. Now, what happens? If you've never seen statistics or studies done on different things, at this point, this is where most of your data should lie. If it's not, they usually throw out the data. So all these people that do research with different things and researching different medicines to cure cancer or to whatever, they're trying to get it in that range. If it's not in that range, they need to throw that test out and start over again. Okay? So it's usually within 5% or 95% accurate is what they say. Okay? Then, one more line. How many deviations away am I now? 3. X bar minus 3 of those. And now I'm adding in 0.0235. 0.0235. I've just jumped it up to 97.5% of my data was within there. And the last one, way out here at the very end of the tails, how many standard deviations am I away now? 4. And then this one, that's kind of hard for me to put it in there because I didn't leave myself enough room. Minus 4. That is at 0.15%, which means that's 0.0015. 0.0015. And if I add all those numbers up, what should I be at? What number should I have if I add every single thing up? 100%? Okay. Now, here's what's going to happen for you. You are going to use those numbers in order to figure out your answers. That's what's going to happen. If you look at, I'm just going to go right to your assignment to give you guys some help on this stuff. If you look on page 760, it says for 3 through 8, it wants you to tell me a normal distribution has a mean x bar and standard deviation of sigma. Find the indicated probability for a randomly selected x value from the distribution. And here's what number 1 says. I'm going to put it in orange just so that we can see it. It says the probability of x being less than or equal to x bar minus the curly Q, or the standard deviation. Okay? Now, what I do on this particular thing, here's how I set this up. I do this where I will draw a bell curve for every single one of these. Okay, I usually do that just because I like to have the picture. Then what I do is I look at, okay, it's saying this line right here. Why do I know it's saying that line right there? Because that's where x minus sigma is. Okay, now am I going to go to the right of that or to the left of it? Left of it. Why left of it, Denise? Because it says less than, right? It says less than. So what I'm trying to figure out is I'm trying to figure out the area under the curve. That's what I'm trying to figure out. I want to know how much that is right there. Now, there's one of two ways to doing it. It's totally up to you, however you want to do it. But one of the ways that I could do that is take 0.135 plus 0.0235 plus 0.0015. What do I get when I add all those together? Zero point what? 16. I'm too close to that. Huh? And I'm done. No. Leave it as the 0.16. Okay? Now, here's a second way of doing it. What I could do, because if I've got all the tails or everything accounted for, this should be from 4 standard deviations away here to 4 standard deviations away there. That should be 100% of the data, right? That's what I told you? What you could do, if you wanted to do it a little bit different way, is you could take 100% and minus all that. If I take 1 minus everything there, it's not as bad as you think. Because if you're right here to the end, that's 50%. Isn't it? That's 0.5. And then this little part right here is 0.34. So if I can take 0.5 plus 0.34, I get 0.84. And then I take 1 minus 0.84, and it's not as bad, if you think of it that way. Okay? That's what we're doing today, by the way. This is how we're finding our numbers. This is it. So our number was 0.16. That's what we got for number 3. Number 4 says the probability of x being greater than or equal to x bar plus 2 thetas. Or not 2 thetas, 2 sigmas. So on the bell curve, my mean is here, 1, 2 standard deviations away. Okay, that's where I'm at. According to what it says, it wants it greater than that. So it wants everything that's out here on this end of the tail. Okay? That's what it wants. So, as far as wanting it there, okay, this number was 0.34. This number was 0.135. Okay? Now, there's a couple different things that you could do. You could take 1 minus all this. And that would give you your answer. Bless you, Sam. That would give you your answer if you took 1 minus all that. Which, by the way, from this end to the middle here is how far? 0.5. So I could take 1 minus all those pieces if I'd like. That will give me my answer. You could also, on another note, you could also add these pieces together if you would like. There should be 2 of them. There should be the 3 standard deviations instead of 4. You can add those 2 numbers together and you're done. Here's another option. You could take 50 or 0.5 and subtract out this part. And that will give you this section right there. It's totally up to you. There are 3 different ways. I just explained how to do that. And it's all dealing with adding and subtracting. It depends on what you want to do. Aaron, because I value your opinion, which way do you want to do it? I'll give you the options. The blue way, the brown way, or the green way. Green way? Okay, so what Aaron would like to do is Aaron would like to take 0.5, because from here to here represents 50% of the data, and she is going to minus out 0.34, and she's going to minus out 0.135. Because this is not included and that's not included, because we want everything to the right of 2 standard deviations away. Does that make sense, Aaron? Awesome. Anybody tell me what 0.5 minus 0.34 or minus 0.135 is? Say it again, Denise. 0.025. Done. That's number 4. Would you like me to do another one of those top ones? Just like that. Yeah, you do not need to make it a percent. If you do, Caleb, I'm fine with that, but you can just leave it as is. Okay? Is everybody okay with that part? That's how you do 3 through 8. And also 9 and 10. Now 11 through 16 is a little bit different. Okay? On 11 through 16, we need to use a formula. That formula is called the z-score. And the formula for the z-score is z equals x minus x bar divided by sigma. Okay, that's the z-score formula, if you want to get it back into those different pieces. Now, me personally, a lot of times, here's what I do for this one. If I'm looking at 11 through 16, it says a normal distribution has a mean of 33 and a standard deviation of 4. Find the probability that a randomly selected x value from its distribution is in the given interval. It tells you everything you need to know. So if I set up a bell curve for that problem, I have the standard deviation, or the mean here, which they told me was 33. Then 1 standard deviation above it, it says is 4 units away. What's 33 plus 4? 37. Good job. What's 2 standard deviations away? 30. Yeah. 37 plus 4 is what? 41. What's 3 standard deviations away? 45. What's 4 standard deviations away? 49. What's 1 standard deviation behind the mean? 29. What's 2 standard deviations behind it? 25. What's 3 standard deviations behind it? 21. And the last number should be what? 17. How are you getting those numbers, Hannah? Subtracting 4. Nice job. Okay? That's all it is. Now, those numbers that I gave you in the original bell curve, the 0.34 and the 0.135 and all those numbers, that doesn't change. Ever. Okay? This is the same as me writing x bar plus 1 standard deviation, x bar plus 2, x bar plus 3, x bar plus 4, and then subtracting them. It's the same thing. Just different format. So on 11, it says between 29 to 37. So it wants this. That's where it wants you to tell me what the probability of it landing there. Now, what was it from here to here again? 0.34. What was it from here to here? 0.34. And what's 0.34 plus 0.34? 0.68. Done. Okay. Would you like me to do another one using this problem? 16. At most, 37. So I'm going to use the blue color just so that we can figure it out. 37 is right here at this standard deviation. Right, Hannah? What does the word at most mean? It's the most it can be. Right. The max. So here's what it wants you to do then, Hannah, is it wants you to find everything that works up to that brick wall and stop. Now, Hannah, let's make this easier on ourselves. This brick wall, or this one right here, was halfway between the entire set of data. That's 0.5. This is 0.34. 0.5 plus 0.34 is exactly the number that you said, 0.84. Nice work. That's not so bad, is it? Yeah, that's all you do. What do you think? Okay, now, on 19 through 27, it says a normal distribution has a mean of 64 and a standard deviation of 7. Use the standard normal table on page 759 to find the indicated probability for a randomly selected x value from the distribution. If you take a look at that chart, okay, that chart, the way it's reading up there, and I'm going to read that to you at the bottom. It says if a z is randomly selected value from a standard normal distribution, you can use the table below to find the probability that is z less than or equal to some given value. For example, the table shows z is less than or equal to negative 0.4 is equal to 0.3446. You can find the value of that by finding the value where row negative 0 is and the column negative 4 or 0.4 intersect. How they got that score, just so that you know from what they did, is they used that formula that I gave you that's at the top of the screen right now. That's what they did. Okay? So according to this problem on 19, if I use that z-score formula, it was x minus x bar divided by the standard deviation. If I'm going to use 68 is the number that they give us there. 68 goes here minus the mean, which if you read the directions was 64, and I'm dividing it by 7 because it told me that's what the standard deviation was. What's 68 minus 64? 4? What's 4 divided by 7? Say it again. 5.7. Does it go on? 0.571. Okay. That's probably good enough. Now let's go to the back, or to flip that over to the previous page. Okay. And now here's what's going to happen. Do you see where it says 0? The positive 0 one? And that's the bottom one because I'm bad at figuring out the camera on this thing. But you see where it's got the 0 one down there? I'll try to focus or zoom in. Okay? We're at the positive 0 because we're not a negative number. Now you told me that it was 0.57, yes? 0.57 rounded is 0.6. If I go to 1 decimal place. What number does that hit? I go across this bottom one. .6 is what number? 0.7257. So I go over to 19. And we said that that number represented on that chart 0.7257. And according to that particular piece, it said everything, or that shows less than or equal to some given value. And if I look at what it says there, guess what it says? Hannah, does it say less than or equal to? Yeah, it does. It says we want the probability of x being less than or equal to 68. That is that number then right there. Now, what if it would have said greater than or equal to 68? Then what I would have done is taken 1 minus the number that was from the chart. I'm done. These problems here are about reading the chart. So let's give us another one and go from it. Nick, would you pick another one?
Let's do 26.
26? Okay, 26 has the probability of 60 less than or equal to x, which is less than or equal to 75. This has got two different pieces, yes? Okay, now, on this particular thing, what we're going to do, Nick, do you want me to do the z-score one or just physically put it in the bell-shaped curve and go from there? Okay, so you want the bell curve and to look at a picture? Okay. So, when we go to that, if we have that thing and the mean was 64, and it says that the standard deviation of that is 7. If I go 7 behind it, that's 57. If I go 7 above that, that's 71, and 7 above that, 78. Here's a problem with this, Nick. Do you see what the problem is? Our numbers are approximately here to here. We don't have those on the chart. We don't know the rule for that. We're guessing where those things are going to be at, so we need to actually use the z-score thing. Okay? I'm glad you tried to do that, but that's why I wanted you to see that it doesn't always work with the picture. Okay? So, first thing I do is I take 60 minus 64 and divide it by 7. And then on the other side I have 75 minus 64 and I divide it by 7. What's 60 minus 64? Negative 4 divided by 7? Should be negative 0.6, right? Because we just had 4 sevenths, so negative 4 sevenths should be just negative that, right? Right, Casey? Good. What's 75 minus 64? 11 divided by 7? 1.57, so 1.6. Okay. Now I'm going to flip back to the chart. Now keep this in mind. Nick, you picked this question, but I want you to keep this in mind. We are doing this as these numbers are representing to the left of these two pieces. Okay? That's what's happening. It says that it's less than all those. So Nick, here's what's going to happen. If I want the stuff in between the two pieces, because that's what it says, if I find this tail first and then this tail second, in order to get the piece that's in between them, I would subtract those two numbers from each other. So the 75 was at 1.6. So according to the chart, once it focuses here, come on you. .6. Go down to 1, over to 0.6. What's that number? 0.9452. Okay, so 0.9452 minus. Now we need the negative 0.06. Or negative 0.6, I mean. After it focuses here, you got to be very careful because this time we're now going to be in this column right here that's kind of already highlighted in pink. Why am I in that one? Because that's got a negative 0, right? And I'm going to go over to 0.6, and I know it's not focused very well, but this one says 0.2743. Okay? So 0.2743. Because what you're telling me by those charts is, that's telling me to the left of both of those two curves. If we want to find out what's in between them, we're going to subtract them. So what's 0.9452 minus 0.2743? Denise, can you tell me that one more time? 0.6709er. And done. Those are the ones that you're going to have to do the most work on, only because of the fact that you have to find the z-scores before you do that. Okay? But that's how you read the chart. What do you think? All right. Hearing or seeing no other comments, then we're on page 760. Ooh. Let's do this then. Let's go 4 to 26 evens. Nice short one for you.